Well, hello everyone. This is Chris again, back for another discussion on fluid dynamics. I'm just going to pick up right where I left off, talking about the Bernoulli principle. And in this case, we're talking about a very special case, or a special consideration of the Bernoulli principle. This special case is known as the Venturi effect. So up here I have a tube. Some of this should be fairly familiar to everyone. I have a flow V going in into the entrance. It constricts, and we know that as it constricts, the flow through here will increase, but the pressure will decrease. So we have P1 here. P1 is high pressure. P2 will be low pressure as it increases. And then we take the Bernoulli principle just a little bit further, and we say, okay, let's say that we open the tube back up again, but we do it at an angle of this is angle theta, less than 15 degrees. What happens when we do that, when we open the tube back up, of course the flow is going to decrease, so V1 and flow 2 is going to decrease, but my pressure, P3, is now going to increase. So I have P1 here, P2 decreases, and P3 increases. And I can reestablish my baseline pressure and flow. This is assuming that the angle theta here, as it opens up, is less than 15 degrees. That special case has to occur. Now, the other component of the Venturi effect is that if I put a little hole right here where the constriction is, as the pressure decreases, I also have a pressure of the atmosphere out here. And what will happen is, as the pressure decreases through this constriction, the atmospheric pressure is going to be higher than the pressure through that constriction. And where is the air in the atmosphere going to go? Well, it's going to be sucked in, or if you want to look at it as the atmospheric pressure is higher and it's going to blow in. Any way you look at it, air from the atmosphere will be entrained at this point because the pressure is now higher outside, and that is how we can increase our flow. When you talk about Venturi masks, air entrainment masks, certain types of nebulizers that use the Venturi effect, you entrain air, and not only do you have a flow here of oxygen, but I'm also increasing my overall flow by entraining air, and this is how I can mix different concentrations of air by manipulating the Venturi effect, and I can have different FiO2s and higher flows. So hopefully that makes a little intuitive sense. Again, it's just a special case of the Bernoulli principle or Bernoulli effect. Thanks, guys.